Can you see the shared screen?
Yes, ma'am.
And my video is visible?
Yes, ma'am, it is visible.
Okay, fine. So let's start. So what we are going to do in today's class? We are going to have some discussion about how to proceed, what we know already and what we need to know. And I'm going to take a small test, not exactly test. We are going to have a discussion to see that how much we need to work on. Okay.
Yes, ma'am.
Okay. So how was class 10th? This is your class 11th now, right?
Yes, ma'am.
So how was class 10th?
It was fine, better than ninth.
Better than 9. Why?
Uh,
It take too much time to adjust with class 9, no?
Ninth was a bit hard, and I don't remember a few things from ninth now.
Okay.
But tenth was easier to study. Tenth was
Okay.
much easier.
10th was much easier. And what are the subjects you like and what you don't like? It's fine if you don't like chemistry. That's fine.
No, no, I don't. I do like chemistry. I don't like physics.
You like chemistry.
Physics is like
You don't like physics. Okay.
a bit hard.
Hmm. So what are the topics from chemistry you have learned already? Tell me some things from chemistry that you know.
Hmm, recently, what I studied organic chemistry about carbon and its compounds, and then
Mm-hmm.
metal. Tenth topics are
Mm-hmm.
like some reactions from the first chapter, chemical reactions and equations, and then
Okay.
acid, bases, and salts. From
Mm-hmm.
ninth, I don't remember much things. A bit
Mm-hmm.
things like Avogadro number
Mm-hmm.
and what's the mole.
So what is Avogadro number? What is the value of Avogadro number?
I think it's 6.022 into 10 raised to minus 23. No, I always get
6.10
the expression wrong.
to the power?
10 to the power, I think minus 23. I'm not sure. I will need to check it again.
And what is the other option you are confused with? What it
The
could be if not
exponent
this?
power,
What should be
the
this?
exponent.
Mm-hmm. What it should be?
Maybe it's 23, not minus 23, or it's 22.
It's 23. You are right. It's not minus
Hmm.
23. It's
Yes, ma'am.
23. Okay.
Hmm.
So how to remember this? What is Avogadro number?
The number of atoms in a mole present.
Number of
Yeah.
atoms present in 1 mole of that atom, right?
Hmm. Hmm. Yes, ma'am.
When you are saying 6.022 into 10 to the power minus 23, if I write it, how do we write it? We write it in a way 6.022 by 10 to the power 20,
23.
right?
Yes, ma'am.
So this is clearly a fraction, isn't it?
Fraction. Yeah, it would be a smaller number.
It would be a
Smaller
smaller
number.
number. It would be something less than
Hmm.
1. So when we are
Yes, ma'am.
counting something, our minimum unit is 1. No, we can't say half human. A
Hmm.
human should be minimum 1, na?
Yes, ma'am.
Yes. So it can't be a fraction. So when we are saying that, when we are introducing this minus, we are getting a fraction number. But when we are
Hmm.
counting, we should start from 1, 1, 2, 3, 4, like that, na?
Yes,
So
ma'am.
this should be an integer. So that's why it's not 10 to the power minus 23, it's 10 to the power 23. And this is a
23.
huge number. Okay.
Hmm. Yes, ma'am.
Avogadro number is a very huge number. Like, I don't think you have come across this huge something till date. Okay.
Yes, ma'am.
So the
Yes, ma'am.
definition of Avogadro number was absolutely correct. Number of atoms in 1 mole of that
Mole.
atom. Okay. So tell me one thing. If and what is can you tell me what is 1 mole? How do you define a mole?
Hmm. One mole is the basic unit to count atoms. Maybe.
Mm-hmm. You can just define mole using the
Mm,
Avogadro number, right? You define mole.
mm,
What you said? You said that Avogadro number is something, the number of atoms there are in 1 mole of the atom, right?
mm. Yes, ma'am.
Now just try to define 1 mole using this Avogadro number only.
1 mole is like a collection of uh, the number of
Mm-hmm.
atoms, the Avogadro number,
Mm-hmm.
to measure. No, no. Wait,
Yeah,
it's
you
like
were
a
going
unit.
right.
Unit of an atom to measure the unit.
It's unit of amount. So how do you define it? You
Hmm.
are saying it right. See?
Number of atoms using the Avogadro number. The Avogadro number is
The
present
amount,
in 1 mole.
yes. The amount of something, anything
Hmm.
that has Avogadro number we denote as Na. You know that, right?
Yes, ma'am.
Na, Avogadro number. The amount of something that has any number of that thing. It doesn't have to be an atom. Yes, here we are dealing with atom, but it doesn't have to be an atom. It can
Hmm.
be any. It can be an atom. It can be molecule. It can be a book. The number of books. If we have Avogadro number of books, which is imaginary, actually it's huge number of books, then we can say that we have 1 mole of books. Okay. So if
Hmm.
we have Avogadro number of hydrogen atom, we can say we have 1 mole of hydrogen atom. Okay.
Okay, ma'am.
And if we have 1 mole of hydrogen molecule, so what is hydrogen molecule and what is hydrogen atom? What will be the
Uh,
symbol for hydrogen molecule and what will be the symbol for hydrogen atom?
Hydrogen atom is denoted by H and the molecule is denoted by H2 because molecule is formed by the bond of two or more atoms.
Very good. Your concepts are very clear. Okay. So if we have 1 mole of hydrogen atom, then if we have Avogadro number of hydrogen atom, we will call it 1 mole of hydrogen atom. If we have Avogadro number of hydrogen molecule, then tell me how many hydrogen atom will be there in 1 mole of hydrogen molecule.
2 into 6.022 into 10 raised to 23 will be the number of hydrogen atoms present in 1 mole of hydrogen molecule.
Very good. Okay. Okay. And can you tell me what will be the weight of 1 mole of hydrogen atom?
Hmm, the atomic
What
mass should be counted as the weight of a
and what
hydrogen
is
atom or a molecule.
so what is the value for hydrogen atom and what is the value for hydrogen molecule?
For hydrogen atom, I think it's 1 and hydrogen molecule, it's 2.
Yes. And when I am asking for mass, you can add gram. Okay.
Yes, ma'am.
1 mole of hydrogen atom is 1 gram and mass of 1 mole of hydrogen molecule is 2 gram. Okay.
Okay, ma'am.
Okay. Now then tell me this question. I am giving you three quantities. Okay. 8 gram of hydrogen molecule. Just tell me if it feels too tough, okay? We can scale it down.
Yes, ma'am. Yes, ma'am.
32 gram of oxygen molecule and 12 gram of carbon. Okay? Now you have to
Yes,
tell
ma'am.
me, this is the three things we have. In which case, 1, 2 or 3, in which case we have maximum number of atoms.
Hmm.
In which case we have, the question is clear?
Yes, ma'am.
Okay. If you face any problem, just ask me, okay?
Yes, ma'am.
Okay.
Mm, I think the maximum number of atoms will be in the oxygen. Will be in the will be in oxygen
Tell me why.
because the atomic mass of oxygen is 16, and then
Hmm?
we are calculating with oxygen molecules. So 2 into 16 is 32. And then if you calculate the mole, 32 into 6.022 into 10 raised to 23. So it will be a really big value. So that's why
Wait,
there
wait,
are
wait.
more number of atoms.
What you said that 16 gram is the molecular mass of oxygen, right?
Yes, ma'am.
So in
Molecular
32 gram
in atom, in atom,
in
in one
atom,
oxygen matter.
in one
And then
oxygen
if we,
atom, we will have
hmm,
16 gram. So one oxygen
hmm,
molecule, it weight 32 gram.
yes, ma'am. So 32
So
into 1 mole will be a
32
really
into
huge value.
what is the number of mole of 32 gram of oxygen? 32 gram of
32
oxygen is
in
how many moles?
32 gram.
I'm asking for
Wait
moles,
one
okay, not
second.
number of atoms. Just tell me moles.
Yes,
Yeah,
ma'am.
32
Yes,
gram
ma'am.
oxygen, then how many mole it is?
Hmm.
See, if I would have asked you that the mass of one mole of oxygen molecule, what you would have said? You would have said 32 gram, na?
Yes, ma'am.
So I have asked you this. If one mole of
Oh,
oxygen molecule means 32 gram, then 32 gram of oxygen molecules mean one mole, na?
one mole. Yes, ma'am. Yes, ma'am. No, I got confused.
Yes, yes, it's fine. So it's one mole.
Hmm. Yes, ma'am.
12 gram of carbon is
I haven't figured out the third one.
what is the atomic mass of carbon?
Hmm.
What is the atomic number of carbon? How many protons a carbon have?
The carbon has.
A carbon has six protons. Okay.
Yes, ma'am. Six. Hmm.
What is the atomic mass of carbon? And it has six neutrons.
Hmm.
The atomic mass is 12.
Hmm.
So 1 mole of carbon will weight 12 gram. Fine?
12 gram.
12 gram.
Yes, ma'am.
That means 12 gram of carbon means 1 mole. Right?
One mole. Yes,
Yes.
ma'am.
Coming to this one, 8 gram of hydrogen molecule, it means how many mole of hydrogen molecule?
Two. No, no, wait.
Mm-hmm. Take your time.
4 moles? No,
4 moles. Yes, yes, yes. 4
4
moles.
moles. 4 moles.
How did you get that?
If 1 mole of hydrogen atom is 2 grams,
Mm-hmm.
then dividing 2
Okay.
by 8, multiplying 2 by 8, no, dividing we get 4. So 4 moles.
So one thing we know that 1 mole of something has Avogadro number of it. Na?
Hmm, yes, ma'am.
That means it has 4 into Avogadro number of hydrogen molecule. And one hydrogen
Hmm,
molecule has 2 atoms. That it means it has
yes, ma'am.
4 into 2 into Avogadro number of atoms in it. Now,
Hmm,
here we have Avogadro number of oxygen molecules. That means we have 2 into Avogadro number of atoms, right?
yes, ma'am.
And here we have only Avogadro number of atoms because we have only
Hmm,
C, not C2, right?
yes, ma'am.
At the three scenarios, so this is 8 Na.
Hmm,
Na is Avogadro number. This is
yes, ma'am.
2Na, and this is only Na. So in which case we have the maximum number of atoms?
The first case.
The first case. So that means that 8 gram of H2, 8 gram of H2 has the maximum number of atoms. Fine?
Yes, ma'am.
Okay. Now you said you have read a little bit of organic chemistry. So how many bonds carbon can make?
4 bonds.
4 bonds. Very good. And what is the shape of it?
Shape.
We have read something like this now. Have you read something like
Hmm.
this? This angle
No.
is 109 degree
No,
28
no.
minute. Now,
No, no.
okay, fine. So what happens is a carbon has 4 bonds and these 4 bonds are not in a plane. Okay. If you think of
Hmm.
what I have drawn here, it's on a 2D plane, right?
Yes, ma'am.
But in reality, it's not like that. The 4 bonds are oriented in 3 dimension. So what happens? 2 among them are in a plane. These 2 I have drawn in a single line. These 2 are on a plane. And this one is below the plane. And this one, the bold one, is above the plane. Okay. So
Yes,
this
ma'am.
is kind of the structure. And this structure we call, this is a very important thing, we call it tetrahedral. Have you read it?
I heard of tetravalency because it has the valency of 4.
Okay, so the structure is called tetrahedral structure. Okay,
Yes, ma'am.
so the orientation of carbon is tetrahedral. Okay, so you have what are the 3 types? If we have this bond, what does it call? And if we have this bond, what does it call? And if we have triple bond, what does it call? Do we know this?
Yes, ma'am. The first one is alkane, the second is alkene, and the third one is alkyne.
This one is alkane, alkene, and alkyne. Very good. And if we have 1 carbon, then what is the prefix? 2 carbon, what is the prefix? Do we know that?
Methane, ethane, propane, butane. Then
Very
it
good.
goes on. Pentane.
What do we call this one? Let me draw it. How many? You tell me the number of hydrogens. How many hydrogen will be here? In this case, for this carbon,
Hmm. 2 hydrogens will be there for the first one.
this will be there. For the second one,
For the second one, only 1 hydrogen.
only 1 hydrogen. And for the third one,
For the third one, 3 hydrogens.
3 hydrogens. Very good. And what we will call it?
Propene.
Propene. Very good. Okay. Have you read about redox reaction?
Redox reaction. Yes, ma'am.
What is redox reaction?
The occurrence of both oxidation reaction and reduction reaction
Okay, so this
occurring in
redox
one reaction is called the redox reaction, where both
okay,
oxidation and reduction is happening.
part comes from reduction and this ox part comes from oxidation. Okay,
Oxidation, yes, ma'am.
call it
Yes,
redox reaction. And what is reduction and what is oxidation?
oxidation, addition of oxygen and removal of hydrogen. Reduction,
Mhm.
addition of hydrogen and removal of oxygen.
Okay, very good. And can you tell me from the perspective of electron? If we add electron, that's reduction or oxidation. Do you know that?
Electron,
Mm-hmm.
hmm, it is reduction. If we are adding electrons, it's reduction. If we are removing,
Mm-hmm.
then it's oxidation.
Very good. So, if we are adding electron, it's reduction. You can read my handwriting, right?
Yes, ma'am.
Okay. If we are adding electron, it's reduction. And if we are removing electron, it's oxidation. Okay. So apart from this, one little term I am going to introduce today. Just a little term, and after that we will move forward to the test, which is
Ma'am.
molarity. This will be something new for you, okay? And also remember the tetrahedral part, other things you knew already, okay? So what is molarity? Molarity is number of moles of a substance Don't worry, we will study it again, okay? I'm just giving an idea. Substance
Yes, ma'am.
dissolved in 1 liter of a solvent. Just because you have a clear idea of mole, I am giving you this idea. So what is molarity? Molarity is number of moles of a substance dissolved in 1 liter of solvent. So molarity is basically unit of concentration. So what is the definition I have told you? I have told you that number of moles of a substance dissolved in 1 liter of a solvent. So if let's say we have uh, sodium chloride, okay? You have
Hmm.
heard of this thing, sodium chloride?
Yes, ma'am.
Okay. So let's say we have sodium chloride and we have 1 mole of sodium chloride, 1 mole of sodium chloride dissolved in 1 liter of water. What is the symbol for water?
H2O.
H2. We have 1 mole of sodium chloride dissolved in 1 liter of water. So we will call it that the molarity of the solution is 1. Why? Because the number of mole dissolved is 1, right?
Yes,
That's
ma'am.
we will call it, we will say that the molarity of the solution is 1 and the unit of molarity is molar, and we write it M, capital M in first bracket. Thus we write molar. So we will call it that it is a 1 molar solution of sodium chloride. Fine?
Yes, ma'am.
Okay. We will come to this again, don't worry. Okay, now let's move to the test discussion part. Wait, let me stop sharing it. So you can see the screen, right?
Yes, ma'am.
Okay. The first question is, write the chemical formula of the following. Barium sulfate. Do you know what is the chemical formula of barium sulfate?
BaSO4.
BaSO4. Very good. Ammonium hydroxide.
Um, NH4OH.
Okay. And aluminum chloride.
As3Cl2.
Al3Cl2. Think again.
Or maybe it's Al2Cl3.
Al2Cl3. You sure?
Yes, ma'am. Al2Cl3. No,
Okay. How do?
Al3Cl2. Al3Cl2.
So this one or this one?
The first one, Al3Cl2.
First one you are saying. Okay. I think. Okay. How do we do it? We do it with valency, right?
Yes, ma'am.
So here, tell me, what was the valency for barium and what was the valency for sulfate?
For barium sulfate, I just memorized the formula because I used it in equation.
Okay, so barium was Ba2 plus and sulfate was
Mm.
SO4 2 minus. Okay, and here
Okay, ma'am.
it was also NH4 plus and OH minus. Okay, so
Yes,
that's
ma'am.
why it had plus 2 and it had minus 2, so it became like BS4 because both of them were same. Here
Yes, ma'am.
was plus 1, it was minus 1, so it became like that because again this the positive and negative charge were same. Now if we
Yes, ma'am.
taste something like, let's not go with H2, let's say we have something like, what we can have, we have yeah, let's say we did barium sulfate, we did ammonium hydroxide. Now you tell me, looking at this, what we have to do, we have to neutralize the charge, right? So let's say,
Yes, ma'am.
what will be the chemical formula for ammonium sulfate? We did for this
Ammonium
one, we did for
sulfate.
this one. Now I am
Mm.
asking you for this one. What will be the formula for ammonium sulfate? We need to neutralize the charge, and ammonia is positive 1 and sulfate is negative 2.
Mm. NH4 2
Mm-hmm.
SO4.
Exactly.
Mm.
NH4 2
SO4.
SO4. Now, do you know what is the charge for aluminium is?
Aluminium. Mm. -3.
No, aluminium is positive. Okay, aluminium is the positive one.
Okay.
The charge for aluminium is positive 3. Okay,
Yes,
and
ma'am.
for chlorine is minus 1. So what will be the formula for aluminum chloride?
AlCl3. Then.
AlCl3. Okay, so it won't be
Yes,
AlCl,
ma'am.
Al3Cl2, it won't be Al2Cl3, it will be
AlCl3.
AlCl3. Fine. Okay. Now coming to question number 2. Question number 2, we have write the electronic configuration of the following. Electronic configuration, you have to tell me in that sense that how many electrons are there in the first orbit, second orbit, third orbit, and how many orbits will be needed. Okay.
Yes,
So
ma'am.
what is the number of electron for sodium?
Sodium.
What is the atomic number for sodium? Because to write the electronic configuration, we first have to know the atomic number, right?
Yes, ma'am.
So what is the atomic number
13.
of sodium?
Is it
No,
13?
13 is aluminium.
No.
13 is aluminium.
Hmm. Hmm. 23 then. No, that's a huge number
We
then.
know sodium lesser than aluminium.
Hmm.
So what is the... Okay, let me give you a hint. Sodium comes after neon. Does that help? Sodium
No,
comes
not
in
really.
between neon and magnesium. Okay. Okay, the atomic
Hmm.
number for sodium is... Okay.
Yes, ma'am.
Now can you tell me that what will be the electron configuration of sodium? That how many electrons will be in the first orbit, how many in the second orbit?
In the first orbit K, it will be 2. Second orbit
In
will
K,
be 8.
2.
Third,
Hmm.
third orbit L, M will be 1.
And will be 1. Very good. Okay. What is the atomic number for chlorine?
17.
17. Very good. And what will be the electronic configuration?
K shell will be 2. L shell will be
Hmm.
8. M shell will be
Hmm.
7.
And it will be 7. And for carbon, I have told you the atomic number of carbon today.
Yes, ma'am. It will be 6. So K shell will be
What
2.
was the atomic? Yeah, yeah.
Yes, ma'am. K shell will be 2. L shell will be 4.
L shall be 4. Very good. Okay. Okay. Coming to the next question. So the question says, an iron rod of uniform thickness of length 2.3 meter weighs 4.6 kg. How much will be the weight of 5 iron rods of the same thickness to length 10 meter? I guess it will be, oh, wait, one second. An iron rod is uniform thickness. Let's do the next question first. I'm coming to this question. Wait. Let's do the question 4. Okay.
Yes, ma'am.
15 men can work together to finish a job in 10 days. How many days will 25 men take to complete the same job? This is very easy actually.
One second.
So it would take more days or less days?
It will take less days. 6
It
days.
will take 6 days. How did you do that?
By applying the inverse proportion formula, x1 into y1
Okay.
is equal to x2 into y2.
So
So
what
we
did you do?
multiply
Tell
15 into 10. 15
hmm,
into 10 is equal to 25 into x. Then 15 into
25.
10 is 150. 150, we transfer the 25 to 150 and then we get 150 upon 25 is equal to x. By dividing 150 upon 25, we get 6.
Very good. So this is inversely proportional, right?
Yes, ma'am.
Very good. Okay. And final question is, show the formation of calcium chloride by transfer of electron. So how do you do that? Do you know how to draw a Lewis dot structure?
Yes, ma'am.
So how to draw that? Tell me, I am drawing it. You instruct me, I will draw it.
For calcium, calcium has 2 electrons on its outer shell,
Mm-hmm.
and chlorine has 7 electrons on its outer shell.
Hmm.
So we draw 2 chlorines because we need to utilize both of the electrons from calcium.
Okay.
We transfer both of the electrons to 2 chlorines from calcium. So we get Ca 2 plus and
Ca2 plus with how
uh,
many electrons in the outermost shell?
uh, for calcium,
Mm-hmm.
we gave the 2 away. So the rest is 8 now in the outer shell, which is the stable form now, which is in
The
stable form.
opposite. I have done it opposite. Right. There will be 8, but the orbit will be the inner one now, right?
Yes, ma'am. The inner
Yes.
one because it gave
Yes.
away its outer shell electrons to both the chlorines.
Right. So there will be 8 electrons here. And for both the chlorines, tell me what will happen to both the chlorines?
It will get a negative charge. Both the chlorines will get one negative charge because it is receiving one electron from calcium.
Okay. It will have negative charge, right? And what will happen then?
Ca2 plus into Cl minus 2. No, the 2 will be on the outside the bracket.
Yes. Ca2 plus 2 Cl minus, and it
2
will,
Cl minus
right.
CaCl2.
Very good. CaCl2. Okay. Uh, just give me 1 minute. I need to check the question number 3. Okay, just give me 1 minute.
Yes, ma'am.
Okay, let's remove this 2 here. Let's remove this 2 here and off. Okay. So the question is, an iron rod of uniform thickness of length 2.3 meter, weight 4.6 kg. How much will be the weight of 5 iron rods of the same thickness of length 10 meter? Okay.
Yes, ma'am.
You understood the question?
I'll try calculating.
Yes, do it. Just part it. It's easy actually. Just think part by part.
Yes, ma'am. I think it's 100 kg if we are multiplying with pi as well. It's asking the weight of 5 iron rods. That's why.
5 iron rods. Okay, how did you solve it? Say.
By using direct proportion, 2.3 upon 4.6 is equal to 10 upon x. No, wait. Wait, I should have multiplied 10 with 5. 1 second. I'll do it again. Wait.
Okay.
Yes, it's 100 kg. It's 100 kg.
So how did you do it?
By
Explain me.
using direct proportion. Uh, by using direct proportion, 2.3 upon 4.6 is equal to 10 into 5 upon x. X is the weight we need to find. We multiply 2.3 upon 4.6, cancelling the decimal. 23
Yes.
ones are upon 23 twos are 46, 2 is equal to 50 upon x. Then we multiply, we take the 2 from the denominator to the numerator to the other side and x to the other side. Then we get x is equal to 50 into 2. Then we get 100 kg.
Okay, okay. Tell me once again, step by step. Okay, I'm asking you, tell me here. So primarily we had length 2.3 meter and weight 4.6 kg, right?
Yes, ma'am.
So, and after that we had thickness, the thickness was same and the length was 10 meter. So let's not think of 5 iron rod now. Let's think of 1 iron rod. So for 1 iron rod, what will be the weight?
For one iron rod, 20, 20 kg.
So you have to do here 4.6 into 10 by 2.3, right?
Yes, ma'am.
Okay, I guess that's what you did. And here we are getting 20 kg for 1 rod, right?
One iron rod,
1 iron rod, and for 5 iron rods you are getting
100 kg.
100 kg. Very good. So this one is done and you have done really well. Okay, so coming back to our notes. One thing I suggest you as of now, let's try to remember the atomic numbers, okay?
Yes, ma'am.
So, what is the first? What is the atom with atomic number 1?
Hydrogen, the first
Then
one. Um, Lithium comes next, I think.
lithium is 3.
Oh, okay. I don't remember the order.
Okay. Okay, let me write it down first. Just remember up to 20 as of now. So first one is hydrogen. So which one among these are noble gases?
Mm,
Number 2 is noble gas,
ye-
and
yes, ma'am.
after
Hydrogen,
number 2 it
noble.
has to be the number of electrons in the outermost shell has to be 8 for it to be a noble gas, right?
Yes, ma'am.
So
Yes,
2 is Mhm.
to be stable, it has to have 8 or 2 electrons in its outer shell. So
The 2
it
electrons
will be
is,
called a noble gas.
and for all the other cases it has to be 8 electrons. So
Hmm.
this is one noble gas. And what others here are the noble gases? If the number is 4, would it be 8 electrons in the outermost shell? No, right?
No.
And this is
The
not a noble.
eighth one will be the noble gas. The
This
eighth
one.
one. No, no, not eight.
Okay. So which
The
one?
tenth one. Tenth one.
One. Very good. And there
The
will be
tenth
another.
one. The 12th one. 12th. No,
But
eight electrons, right? So
yes, it has
18th
to
one then.
be 18th one.
Hmm.
Would the 21 be a noble gas?
21.
This 20th one.
20. Yes, man. 2020.
This will be a noble gas. What will be the electron
Hmm.
configuration? The electron configuration will be 2, 8, 8, 2.
2882. No, it won't be a noble gas. It has two in the
Gas,
last
yes.
shell.
For only this case, 2 is considerable, okay? For the other cases, it has to be 8. Okay. So
Okay, ma'am.
let's first see the noble gases. The first noble gas we have helium, sorry, not lithium. The first noble gas we have helium, which is 2. Then at 10, we have neon, and at 80, we have argon. Okay, I'm writing the whole names.
Hmm. Yes,
Neon
ma'am.
and argon. Okay,
Yes, ma'am.
you can treat them as checkpoints. Fine.
Hmm.
First we have hydrogen, then we have helium 2, lithium 3. What is 4?
For
We
no,
look at our
I have
periodic
no
table.
idea.
Wait, let me draw periodic table, structure of that. So it looks like this. Here it is something. Here we have something. Then we have two things here, and we have
Hmm.
few things here. This is 1. This is 2. Then here we have 3, 4. Here we have 5, 6, 7, 8, 9, 10. Okay.
Yes, ma'am.
Then we have 11 and 12 here. Then here we have 13, 14, 15, 16, 17, 18. And after that, here we have 19 and 20. So these are the columns. This is one column. 1, 3, 11, 19. It's one column. The second column is 4, 12, 20. Here we have another column 5, 13, and so on. Here we have 2, 10, 18, and so on. So this is a column of our noble gases, right?
Hmm. Yes, ma'am.
So like this, we have to fill it. So when we come to 4, the 4 one comes here. This is beryllium,
Hmm.
not barium, beryllium, okay? Barium
Yes,
comes
ma'am.
much later. This is beryllium. In 5, here. Here it comes boron. 6, we know carbon.
Carbon. Yes, ma'am.
7, we have nitrogen. 8, we have oxygen. 9, we have fluorine. 10, we have neon. Then 11 is, we have done it today. What is
Ah,
11?
sodium. Sodium.
Sodium. Sodium we denote as Na, right?
Yes, ma'am.
Sodium. Then 12 is magnesium. 13 is aluminium.
Hmm.
14 is silicon. 15 is phosphorus. 16 is sulfur.